Okay, so add these two fractions, these two rational algebraic expressions. To do that, I need a common denominator first. As I look at, numerator, denominator, I can see that all of them are in factored form with the exception of the denominator of the first term. So I'm going to factor that. Let me just go ahead and first of all rewrite the x minus 3 over, and in its factored form, this is an x and an x and an x. And factors of negative 4 that produce a sum of 3 are positive 4 and minus 1. And then over here I'm adding 2x over the x plus 4. So again, what's revealed by factoring is that I can see that both of them have a common factor of x plus 4 in the denominator. And the only one that needs modification is the second fraction, right? This one needs a factor of x minus 1. So to accomplish that, I'm going to multiply this other fraction by x minus 1 over x minus 1. When I do that, I can see now I have identical denominators, and I don't need to really multiply that out. I'm just going to leave it like that, right? X plus 4 times x minus 1 is my common denominator. And I am adding these fractions. Let me grab this and move this down just a little bit. This is x minus 3, and I'm going to add to that 2x squared minus 2x. So if I collect up like terms and simplify that, it looks like I've got 2x squared minus 1x and then minus 3. Just something to think about. If I was to identify values of x for which this original expression here is not valid, right? The things that I can see when I look at the factored form and the sums is this expression doesn't make any sense if x is either negative 4 or positive 1. And I can see that from my answer here, right? X cannot be negative 4 and x cannot be positive 1. So there are two restrictions there. But that's basically the procedure that we use for adding some fractions. And it's very similar if we are dividing. I'm sorry, if we're subtracting. This is adding. We're going to look at subtracting next.